What I'm going to talk about is, I'm going to talk about several things. I'm going to talk about, first off, what I think is wrong with Web3 today, and spoiler alert, it's on the slide. The second thing I'm going to talk about is zero-knowledge cryptography, and why I think that's the solution to the problems facing Web3 today, and what is ultimately going to enable adoption and commercialization at the scale of the internet. And lastly, I'm going to talk about Aleo, which is our layer 1 blockchain, as it says on my shirt here, Aleo. By the way, this always comes up, so it's Aleo, like rhymes with paleo. There are many pronunciations out there. Even our own advisors don't get this right, so don't feel bad if you don't remember, but if you need to remember paleo, Aleo, that's how you think about it. But anyway, the last part of the talk, I'm going to talk about Aleo and what that is, and how we leverage zero-knowledge cryptography in a new paradigm at the layer 1. So, okay, who am I? So I'm the executive director of the Aleo Network Foundation. Prior to this, I worked at a company called Aleo Systems Incorporated, which is what basically, is the organization that created the Aleo blockchain, which, by the way, launched today. I told a couple of people before, but today was our mainnet launch. Thank you. 5 years later, I had much more hair and much less gray hair than I do now. But big moment for us, very excited. And anyway, I was at Aleo Systems Inc. before we broke off and created a foundation. Prior to that, I was an investor. So I've been in crypto total professionally for about 7 years. I was at A16Z Crypto before, during their first fund. And that's how I got, kind of really interested in ZK and learned about Aleo. Before that, I was a student. I was at Stanford, and I was a business student, but I was moonlighting in the computer science school, trying to learn as much as I could about crypto and blockchain. And I really had no business being in most of the classes I was in, because before all of that, I was a U.S. Army Green Beret, and I had absolutely no technical background whatsoever. But I got interested in the space, specifically working in the Middle East with people, the Syrian rebels and refugees. And I got interested in Bitcoin specifically as a mechanism to do cross-border payments and wealth transfer for refugees. So that was how I got initially interested in the space. Okay, so if you remember nothing else from this talk, remember these 3 slides. This is what I'm going to talk about today. So, having been in the space now for about 8 years, I believe that Web3 has reached a turning point where it's grown tremendously. I mean, I can remember in 2016 the size of the market was tiny, and now we have a very large Web3 market and a lot of different applications. So much stuff going on. However, most of those applications are centered around speculative use cases instead of real-world use cases. And I think realistically, for Web3 to gain the commercial potential, to ultimately achieve the commercial potential that it has, we need to move beyond those speculative use cases. How do we do that? I believe that this innovation called zero-knowledge cryptography holds the key to moving beyond speculation in Web3. And I'm going to talk a little bit later about why I believe zero-knowledge cryptography is really a breakthrough, but the very high level is it breaks the existing paradigm, which is that you either, in order to verify that information is correct, have to see the actual information, right? Zero-knowledge cryptography is at a very high level of technology that enables you to verify that some information or data is correct without seeing the underlying data itself. And that's a very powerful paradigm that has a lot of applications in what we'll talk about. Lastly, Aleo really tries to take these ideas and implement them into a new for all of this come before, but it takes these ideas and specifically a lot of the core tenets of zero-knowledge cryptography and implements this in a new paradigm and hopefully exposes features that developers can then use to build applications that are focused on real-world use cases, things like identity, things like tools, privacy, machine learning, and then enable these real-world use cases and ultimately kind of break out of this speculative quote-unquote rut that I think we're in. So that's what we're going to talk about today. So starting with the first one, Web3 needs to evolve to grow. So this is what we always talk about. Like here, it's like if you're telling your mom or somebody, you're like, hey, she's like, why are you interested in crypto? Isn't that scammy and weird? And you're like, oh no, mom, no, this is why there's all these use cases, right? And we talk about some things like this, payments, identities, often cited gaming, and more recently we've talked about machine learning use cases in blockchain, AI, ML on blockchain. So, however, if you look at the state of the market today, and you just compare it to the NASDAQ as a proxy for like the total technology sector market cap, right? You can see that all of crypto is a relatively small fraction of this, despite the amount of volume, amount of hype that surrounds technology. That's even kind of an overstatement around the real value, because the reality is most of this market cap is just tokens that people have, are kind of basically speculating on the value of. There's not like, it's not quite clear that these are perfect comp because all of there's a company here that makes revenue, and I'm going to apply to that revenue number, and that's going to, translate somehow into the stock price. That doesn't really exist in the same way in crypto, and so I think it's useful to kind of break it down a little more and think about businesses in crypto actually make money, right? And so if you look at this, this kind of, I think, these are the money-making businesses in crypto. So you got exchanges, stable coins, roll-ups more recently, and the analytics companies. So if you take out all of the tokens, now you're left with this, right? So these are businesses that are powered by crypto and powered by the technology, and that have real products that people can use to make money, right? And I think, again, crypto is not about just making money, but I think it's a good proxy for showing the utility that people see in it, right? It's like if you have a product, if you haven't, if you see someone with an iPhone, you're like, wow, that looks like a really cool piece of technology. I would like that, and maybe you'd be willing to pay for something. So I think this is a proxy for utility of a technology. But if you break down the revenue numbers in crypto even further, most of the revenue is in the top left quadrant, right? And really the exchanges are kind of like, it's really in the same category as, broadly speaking, the market cap of all the tokens, right? Exchanges are where people buy and sell tokens, and people, maybe speculate, is this going to go up? Is it going to go down? And of course, exchanges earn fees on that activity. And so if you cut that out, you're basically just left with this handful of crypto businesses that, and this is based on valuations from 2021, mind you, so like, honestly, this may even be inflated, but you're left with a small fraction. The only one, and the largest one here is kind of the exception that proves the rule, which is Ripple. So Ripple is a payment startup, but the vast majority of their value is in the XRP token, which they themselves created. So, I think even though we've come a long way in the last 8 years, I think we'd be fooling ourselves to consider that Web3 is on the cusp of really changing the world. I think it has, the potential of Web3 and of blockchain technology has not changed, in my opinion, since I got into it. But I don't think we're that much closer to realizing the goal of seeing this solve real world problems. And why is that the case? I'm going to skip through this because I've already kind of made the point. So, again, I think this is the case because I think the vast majority of energy is focused on speculation. And I think there's a lack of features that enable people to build products that go beyond speculation. We're going to talk about some of those in a minute and how to solve for that. The good news is there's an analogy here I think is maybe a little bit, a positive, I guess a positive or encouraging analogy, and that is the internet. In the beginning of time, in 1995, the total market cap of all internet companies was $13 billion, right? So tiny, tiny little fraction of what it is today. How many people here use Netscape Navigator? Who remembers Netscape Navigator? Classic, or Mosaic, yeah. So, so back in 1995, basically nobody saw the potential for all of these internet businesses or the internet generally either, right? Paul Krugman from the New York Times wrote the famous article talking about how the famous, op-ed how the internet was not going to amount to anything. So, everybody underestimated the internet, but ultimately the internet now, I think, is really, it's not an overstatement to say that the internet is arguably the largest commercial platform on earth, right? Every single business in the world uses it. Every single person, more or less, uses it to transact in some way, shape, or fashion every day. And, how did we get from there? How did we get from 13 billion to where we are today? Well, the internet back in the day was basically just a collection of message boards, right? Even before browsers is basically what you did. If you had like a text-based interface and you like talk to people on Genie or whatever, it was all message boards, right? And people were always interested in being able to buy and sell things online, but why didn't we do that? Well, it turns out the original HTTP protocol and HTTP, TCP/IP, all these protocols really kind of weren't built with encryption in mind, right? So anything you sent over the network, you pretty much had to assume that it propagated to any node on the network. And you can see kind of obviously why that would be bad for payments, right? If you have a credit card number, you're like, hey, I would like to buy, a Beanie Baby, speaking of a 90s throwback, to buy a Beanie Baby, I'm going to give you my credit card number. Well, now everybody on the internet probably now knows your credit card number, whoever that is. Anybody who said, who's has a router or a server anywhere probably now has your credit card number. And so this was a problem that actually Netscape famously solved by authoring the SSL protocol. So SSL stands for Secure Socket Layer, and really it powers HTTPS at a high level. It ultimately led to TLS 1.3, which is now what, like the little lock in your browser, is basically showing that your session is encrypted via TLS 1.3. But that started with Netscape basically creating encryption and enabling people to talk privately between each other across this network. And that is really what enabled the commercialization of the internet. And I think in the spectrum of crypto, I think we're like here for the same reason. Why is that? Because all blockchain transactions today are public. So if I want to pay, it's the same problem I just highlighted with Beanie Babies. If I want to buy a Beanie Baby and use Bitcoin, well now forever and ever, the address that I used to buy the Beanie Baby and the recipient of the funds that I spent are known to the world. And it's even actually a little worse than the case of the internet, where like you at least had to like run a server and record all the messages you were receiving. But now it's basically like a giant bulletin board where it's there forever. And you don't have to think about that much to consider how that would be problematic for any large business, right? Or even a small business. Think about, hey, I have a supplier, I've negotiated among 3 suppliers, I ultimately chose the one that gave me the best deal, and then suddenly you have to post your contract up on the internet, effectively, on a giant bulletin board, and then everybody knows all the details of that deal. So for real economic use cases, privacy and encryption is really essential, especially for this one. And I think, I've kind of talked a lot about crypto as like, hey, it's all speculative energy, but stablecoins I actually think hold the most promise for real world use cases, right? And you can even see, I should have put like the price of Ethereum or something as a backdrop to this, but you can just see like, market cap wise, USDC and USDT have become pretty, popular, tokens on blockchains. And for those of you who don't know what a stablecoin is, it's basically just an asset where there's, some entity has a deposit of dollars or treasuries or something, and they issue something that's dollar-backed, right? So it's a dollar-backed asset on chain, so it's supposed to mirror the value of a dollar. So basically it's a digital dollar. And you can see there's a lot of demand for these things, but I think to go beyond what the current use case is, which is mostly people in foreign countries who want to have dollar exposure, if you want to go from that to a real-world, real-time payment system, again, same problem, you need to solve the privacy issue. So this is where we now get to zero knowledge and where I think the promise of zero knowledge is. So zero knowledge is the future. What does that mean? Well, first we got to talk about what is zero knowledge? What are we even talking about? So just as a caveat, this is not going to be a crash. So I'm a former Army infantry officer. I'm not like a researcher. So you're going to get the Army infantry version. I'm kind of, I think there's a lot of depth to this topic. But for our purposes here, it's actually not that important that we understand how these things work under the hood. Now, I think it's a fascinating topic in its own right, but I think for the purposes of this talk, I just want to talk about what the implications are. But I want to define a little bit what it means to start. And since we're in Wyoming, and since I live in Montana, I'm going to use an analogy that some people may appreciate, which is, imagine an interaction between 2 people, Alice and Bob. And Alice is, she shot a 5-point. Bob's like, really? I don't believe you. Prove it, right? And so this is a concept in computer science known as interactive proofs. I make a statement, the verifier then says, prove to me that statement is true. We have at the end of the conversation, the verifier, the other end of the conversation, accepts or rejects my statement. So this is a concept that's been around in computer science for a long time. And actually, this is basically what motivated the creation of zero-knowledge proofs was this concept of an interactive proof. So kind of taking this here and applying it in a zero-knowledge concept, basically what zero-knowledge cryptography enables you to do is take that interactive conversation, model it or translate it into a series of mathematical statements, and the mathematical statements in the overall proving system should achieve 3 properties. 1, should be sound. I should not be able to prove anything, or rather, any statement that could be proven can be proven within the system. So anything, like I can really, basically it's saying like the proof system can cover any statement that you could conceivably make, right? There's not some statement that I could make that wouldn't be covered by the proof system. The second is, so that's completeness. The second is, I guess I've went in the wrong order. Soundness means if I have a false statement, I should not be able to convince you that it's true except with negligible probability. Right, and negligible in this sense means like, there's less of a chance than, 1 over the number of atoms in the universe. It's type of negligible. And last but not least is this zero knowledge piece, right? And zero knowledge is actually kind of an interesting consequence of designing these systems, where it turns out that in the course of proving to a verifier that a statement is true, you actually don't need to reveal the statement itself, right? And this has a lot of interesting implications when it comes to blockchains, and we'll talk about that now. Okay, I guess the only other thing I'll say here, let's skip ahead here. So, so this field was developed in the 80s, and it's been decades of work to get to where we are today. You don't need to remember any of these very arcane names, although it does seem to me that ZK researchers love to try and confuse everybody with a whole smattering of names and different acronyms that are the same but mean different things. The big takeaway is that this technology has been rapidly advancing over the past several decades, and in particular in the past decade, with cryptocurrency and blockchain as a major motivation. So, so this is a chart just kind of showing some of the advances in proving times for some of these various systems, and just basically like the takeaway from the last 2 slides is that this technology is actually practical. And I'm going to talk about Aleo in a little bit, which is basically an application of ZK. But before we get there, let's talk about what does it do? Why do we care about it? Why is this good in the blockchain context? Well, first off, I already hopefully have convinced you of the fact that confidentiality or encryption for individual peer-to-peer transactions is important for real-world business settings, right? So that's where the data confidentiality comes in. That's, I said zero knowledge proofs. What's one of their properties? Zero knowledge. The verifier doesn't actually have to know the statement being proven. The second advantage is that this is a cryptographic statement, right? What does that mean? It means that it's, again, the soundness property. I cannot make a false statement in the system except with negligible probability. Why does that matter? Well, if we think about like many real world like compliance use cases today, think about money laundering, like AML checks. I mean, those are basically just all human level systems where people are like checking, like, okay, this account doesn't appear suspicious, so I'm going to let this transaction happen, right? But there's no real like cryptographic guarantee or mathematical guarantee that something suspicious isn't happening. And we'll talk a little bit about the balancing of privacy and regulation in a little bit. But spoiler alert, 99% of money laundering today happens through large banks, right? And why is that? And that's the case because I'm arguing that you don't have a cryptographic guarantee of the validity of someone's payment. So this cryptographic guarantee, I think, is a really important property. And lastly, scalability. So I didn't define one of these acronyms that was on an earlier slide, ZK SNARKs. So ZK SNARK stands for, there's going to be a quiz on this, so listen up. Zero knowledge, succinct, non-interactive, argument of knowledge. Okay, but don't remember any of that, but the word I want you to remember is succinct. So one of the other interesting properties of this system is that it turns out you can have this gigantic statement, you have a long story to Alice or Bob about the 5-point elk you shot up in the medicine bows, but it turns out you can actually prove that that's true in a much shorter statement. So your proof can be much, much shorter or more succinct than the actual statement. Now, why is that important? Well, what's a big limitation of blockchain-based systems? What's the thing everyone complains about? Oh, Visa can handle 50,000 transactions per second and Ethereum can only handle 1 or whatever, right? But the nice thing about these systems is you can succinctly basically compress a lot of information into a single statement, and that enables a really cool, interesting form of scalability that some blockchain, that has already seen blockchain, frankly, through there's applications called zero-knowledge rollups. For those of you who aren't familiar with layer 2s, there's a whole concept of ZK rollups, and ZK rollups actually don't leverage any of these properties except for the scalability piece. It's all about packing a large number of transactions into a single transaction. So, with that, okay, I think I might have to start skipping ahead because I might be running a little short on time. So, this is a survey we did a couple months ago, just basically showing that, and I'm showing this slide because oftentimes when I give this presentation, people are like, Alex, that's all great that you think privacy is important, but no one really cares about privacy. And we did a survey that shows actually people do care about privacy. So even beyond what I'm saying around businesses, I think people do care about it. And again, zero knowledge cryptography enables people to protect their personal data. And I think goes beyond like an individual liberty point. This is actually something that businesses all crave. Think about the cost, and some of you may run businesses, but consider the cost of a business for securing somebody's personal information if they've like a user data, like login data. Think about actually a perfect example. Credit score companies, right? Credit score companies basically have a database of everybody's personal information, social security number, credit history, etc. The cost to secure that data is relatively high, which means they're always cutting corners and not really doing it well. And then what happens? Spoiler alert, gets hacked. And then not only does all the users' data get leaked, which is bad, but also the company has liability. So in fact, most companies, I think, would much prefer a world where user data was kept on a user device, but a user was forced to prove, hey, my data has a certain character, or have this criteria, and I can, have a loan. So I think there's a real reason why privacy is important, not just for individuals, but business as well. Okay, the second piece here that I talked about is the guaranteed validity, and this is actually an area where I think zero-knowledge cryptography goes beyond blockchain into the world of the internet. Has anyone seen this video? It's like there's this tool that just came out that I think uses DALL-E or ChatGPT, and it basically lets you put a JPEG in of a person, and then in real time, you may have that person's face projected on your video, right? So kind of the perfect tool for scammers, right? And, I think this is kind of a little bit of a toy example, but the point being is that in the world of AI, in the age of AI, where user-generated content will be prolific and very hard to distinguish, or like AI-generated content will be prolific and very hard to distinguish from a user-generated content, the problem of authenticity of the data that we see is going to become extreme. And this is not a problem for the future. I have a very good friend who works in the crypto security industry and at a big custodian, and they had a client lose $30 million because a cyber criminal ring basically was able to spoof their digital asset custodian with a fake video call and say, hey, transfer my Bitcoin to some address. And they thought it was him because it was literally this tool in real time, right? And so I think this is something that faces an issue that faces the internet. And so again, this is back to what I said about ZK. It's the cryptographic nature of the statement to prove the validity. There's not a way, if you're applying, creating through a zero-knowledge identity protocol, and you're doing some kind of effectively handshake using that before you get on a video call, then you can be convinced that the person you're talking to on the other end is actually the person. And the last piece is scalability. So this is, I think, applies mainly in the blockchain context, but some old data from 2020, but the point still remains. Blockchains in general, in the monolithic kind of older architecture, everything has to get re-executed by all the nodes. That makes it quite costly for any individual transaction. And again, zero knowledge lets you take one transaction and takes that from being a single transaction to a batch of transactions. So lets there be more efficient, more scalable, more efficiency and more scalability in the system. Okay, so hopefully at this point in the talk, I've convinced you that privacy is the key missing feature for crypto and Web3, and that, if solved, will help enable Web3 reach kind of commercialization at the level of the web, and that zero-knowledge cryptography is the most promising, or is a technology with a lot of promise to solve some of those core problems. And I'd like to conclude the talk by talking about Aleo, and what is Aleo? So, at a very high level, Aleo is, we like to say it's ZK by design, but we purpose-built a new layer 1 blockchain with zero-knowledge cryptography in mind from bottom to top, right? And if we have time for questions, I'm happy to talk about why we chose to do that instead of build on Ethereum. But I guess maybe I'll just start by saying Aleo, and I mentioned this at the beginning of the talk, Aleo is not a revolution. I like to say it's not a revolution, it's an evolution. And I think way too often in crypto, we have very short attention spans in Web3. And it's important to recognize that people have been working on these problems that I'm talking about for a really long time. Does anyone here know what DigiCash is? Or does anyone know David Shum is? So, okay, yeah, so there's one person. So David Shum is like this legendary cryptographer and kind of the original cypherpunk. And he worked on him and several others worked on all these systems that preceded Bitcoin that absolutely never went anywhere, right? And Bitcoin kind of broke the paradigm. Bitcoin invented a new paradigm of this, basically this blockchain, right? This concept where, hey, you've got all these people that aren't affiliated, and there's one economic objective, and if they all row in that direction, the whole thing kind of works. Ethereum created this model of programmability with smart contracts and implemented basically smart contracts on a blockchain. And why is that important? Well, I think, because there's a name on here that I've kind of glossed over, which I shouldn't, is Zcash, right? So Zcash was a zero-knowledge cryptography or zero-knowledge blockchain in the model of Bitcoin. Now, why isn't Zcash taken off? Well, I would argue it's not taken off because it doesn't give a programmer or a developer the same level of power or control over their application as something like Ethereum. I think this is why these days you see most people really interested in things like Ethereum, things like, and the various, kind of the garden varieties of different smart contract blockchains. So Aleo tries to take, though, the innovations of Zcash and the innovations of Ethereum and combine it into one. In fact, if you don't remember anything else about Aleo from the talk, all you need to remember is Ethereum and Zcash got married and had a baby, and that baby's name is Aleo. So that's basically the way I sometimes like to describe it, okay? So what we're trying to do is build a system that combines three properties. Permissionless, and I think this is, to me, this is a very important piece. This is why there's a token in the Aleo blockchain, because I believe, these decentralized blockchain networks without tokens are not truly permissionless. So we have our own token. Again, it is the mechanism by which everybody's economic incentives are aligned, and there can be a multitude of unaffiliated actors, and I don't want to run a system like this anyway, so there can be a multitude of unaffiliated actors that all coordinate together. That's why it's permissionless. Programmable, so it's a smart contract blockchain, and I'll talk in a little bit about our domain-specific language, Leo, but we basically give the developers the ability to write arbitrary programs that do all kinds of different things, and I'll talk about some examples in a minute. And lastly, private, right? So the nice thing about these programs is that if you have a program that you're interacting with as a user, you can actually choose what inputs you're going to keep private and what you're going to publicize. And the inputs that you keep private, you can prove very fast those. More flexibility than you get in another smart contract paradigm. So in short, Aleo is the first programmable, permissionless, privacy-preserving platform for decentralized applications. Okay, so this is, in a little bit more detail, coming, about the Aleo stack here. So I mentioned already we have our own programming language. Alex, why don't you just use something like Rust or Solidity or something that everyone knows? Well, because of the underlying paradigm of zero-knowledge cryptography, I glossed over all the technical details, but the high level is the representation of a program in zero-knowledge differs tremendously from the representation of a program in a traditional kind of VM, right? And so there has to be a lot of translation done between this cryptographic domain, where ZK proofs live, and this execution domain, which is like what your computer does, okay? And so this requires really not so much the language as much as a specialized compiler, right? But Leo is a language, and really the core of it is this compiler, which lets people basically write in English, hey, I want to do this, or not English, but like JavaScript or Rust-like syntax. Hey, I would like to do this. I want to add two numbers. I want to prove I added two numbers, and take that and then compile it down into a zero-knowledge proof defined over finite fields and elliptic curves, okay? Snark VM is really the core of where the zero-knowledge cryptography happens, right? That's our equivalent of the EVM, right? So people are familiar with Ethereum. Like the EVM is like basically the virtual machine that all the nodes run and then execute in parallel the various instructions. And then SnarkOS is our hybrid proof of work, proof of stake system that is basically what all the node operators on the network run. And if people are curious, I can talk a little bit maybe during questions why we chose a hybrid system. But in the interest of time, I'm going to move ahead here. This is just kind of talking about a little bit what I mentioned. This slide is showing a little bit earlier what I mentioned around you have these two separate domains, right? The need to generate a proof, which is represented very abstractly, and then the need to execute that logic on a computer. And so Leo compiles down to what we call Aleo virtual machine instructions, and then here's a couple of examples, and then it has to generate the proof and execute the program. So why there's a specific or a domain-specific language. So and I've talked a little bit about how Aleo's scalability can be an advantage when it comes to costs. Cool. I think blockchains, the biggest killer use case is finance, right? I mean, this was the motivating use case behind Bitcoin. I can't remember how Satoshi put it. I think it was a digital peer-to-peer payment system or something. That was the original vision. I think finance is really the killer use case. Why? Why is finance the killer use case and not something like gaming? A lot of people say gaming is like a cool use case for blockchains. I think finance is a killer use case, frankly, because the existing financial system, apologies to anybody who works in it, kind of sucks at a high level, like at least if you consider it in the context of the internet. Like think about sending an email. I want to send an email to my sister lives in the UK, that takes mere seconds. If I want to wire my sister money, That's a much more complicated process, right? Blockchains have the potential to enable that to happen much more quickly and much more frictionlessly. As my old boss at A16D used to say, send money like as quickly as you send an email. Why do people not do that today? Well, I already talked about the privacy thing, but there's another consideration we haven't really talked about, which is that what else do banks do when you wire money? Well, they KYC you, they make sure that you're not sending, or any recipient, they make sure that you're not sending money where you shouldn't be. So there's this prerequisite for some kind of identity protocol, right? And if we're in this permissionless, decentralized system, how do we ensure that Alex isn't just sending Kim Jong-un money for his nuclear program, right? And so that's why I think identity and finance in blockchain context go use case is maybe even useful to understand why the policy is, right? So think about whatever a bank, I don't know how many people here have like opened a bank account recently or wired money or had to do any kind of KYC process. Typically, what you have to do is take a photo of your passport and just like email it to somebody who presumably is securing this somehow or hopefully reading it after they verify that you actually have a valid identity document. I think that leaves a lot of room for improvement, right? I think what you really ideally want is someone to cryptographically verify the attributes of your identity as attested to by potentially a government. And, assuming that they are able to cryptographically verify that you are a citizen of whatever country and you're not sending money to a bad person or whatever it may be, then potentially that's really all the information they need to know. They never need to know anything about you other than those facts, and they never need to keep any data about you, right? And the good news is this is possible with Aleo. In fact, we built a proof of concept called ZPass based on a really cool paper. If anyone's interested in reading it, one of the co-authors of the original Aleo paper, but the paper that I'm referencing here is called ZK Creds. And it's a use case. It's a little bit of a toy use case, but it's the idea of proving you're over a certain age without revealing your driver's license or passport document. By the way, I think just that use case alone has a massive amount of potential utility just with regard to the web. You think about content that's kind of suited for minors and not suited for minors, and how there's really no foolproof way on the web to make sure that whatever user is logging into the site, they're of the appropriate age. But leaving that aside, this is an application we built on Aleo to prove your age using a government-issued passport. So what happens is you scan your passport. Every passport, at least new passport, has an NFC chip. NFC chip gets scanned. There's a digital signature on the data there. That signature gets verified in zero knowledge, and then you have a record that gets uploaded to the Aleo blockchain, which is encrypted to everyone but you. And then you are able to use that record, and you are testing two things whenever you do. One, that this is a valid record as issued by a government, and two, I'm over 18, right? And so I think from this, you can build basically a full-on payment system that's more compliant, more regulated, and than you would actually be able to have in the existing use case. Now, let me go back to the compliance piece again. 99% of money laundering happens through banks, right? And it's not like compliance policies at banks are particularly working necessarily, or sanctions regimes of countries. Why? Well, because North Korea has a nuclear program, right? If these things worked, then that wouldn't exist. So I'm actually arguing a little bit counterintuitively that a system like this, while it preserves user privacy, actually makes compliance more effective at the same time. And I think that's something that I think a lot of people overlook. So I already talked about how I think this fits into a broader stablecoin ecosystem, and here's a couple more use cases that we like to think about at Aleo while I conclude the talk. Age verification, I already mentioned, is an unsolved problem for the web, and I think something like Aleo and ZPass can be a solution. Medical data, right? Like several of these, you're kind of getting a theme, like what's personal information that I don't want to just reveal online. Medical data is something that I think, again, has been a persistent problem that people have tried to solve for a very long time. Again, this paradigm also applies there. Credit, we talked already, I used as an example, a credit agency that's giving you a rating. Obviously, all the personal data that you would not want to share also applies there. So, in conclusion, we at Aleo are trying to be the Netscape for blockchain. And really, we're trying to be the SSL for blockchain, right? So we are a protocol enabling permissionless, privacy-preserving, and programmability to developers. We're giving developers those tools to be able to hopefully help Web3 achieve its commercial potential by enabling all of the use cases that I just talked about. And I would be remiss to say, so actually, no one asked, Alex, why are you here? It's Wyoming. So Aleo is actually headquartered here in Wyoming, and I would be remiss to say if I didn't say a few words of why we chose Wyoming. First off, I'm a Mountain West guy. I grew up in Arizona and I live in Montana. But that's not why we chose Wyoming. We chose Wyoming because Wyoming has long been a center for innovation, right? Some of you, probably most of you know that Wyoming was the first state in the country to allow women to vote. So I think forefront of political innovation. And then now in kind of modern times, Wyoming is really leading at the forefront of the renewable energy industry, right? Wind power specifically. And on the blockchain front, legislation like DUNA and all of the legislation around DAOs and the laws pertaining to DAOs being able to open bank accounts, et cetera, is really cutting edge, and there's nothing quite like it in the United States. So for all those reasons, we're very proud to call Wyoming our home. 1601 Capitol Avenue in Cheyenne. You might not always find me there, but that is where our headquarters is. So cool. So that's it. That's Aleo. Thank you guys very much for being here. Hope you enjoyed the talk. Yeah, we got, I think, I don't know, how much, do we have 5 minutes? I don't know how much time we have. We have 3 minutes. Okay, 3 minutes. I was trying to take 3 questions. Question a minute. Let's see if I can do it. Please.
Yeah, a little bit more about a before. I know this space really well. We work with ZK Bruce and everything you said was accurate. This was an excellent presentation. My question is, how are you handling the compute for the ZK proofs on Aleo versus what I'm doing now on EVM, where it's all floating in compute to parties who are using off-chain computation to prove out?
Great question. Great question. This gets to the core of why we built a new layer 1 blockchain. The EVM, so it's, you can actually do everything I described here on Ethereum, mostly, right? And what's the trade-off? The trade-off is that if the Ethereum virtual machine was meant to be very general purpose, right? The opcodes, when they designed them back in 2015, were kind of just supposed to mimic like a general purpose computer. There's no ZK specific opcodes or ZK specific curves, and when I say ZK specific, I mean optimized for zero knowledge in the EVM. So that means it's actually really expensive, gas-wise, to do verification, proving even more so in the EVM model, which is why most zero knowledge projects that are built on the EVM have exactly the model that you described, which is that you outsource the data to a prover that generates the proof. And then that proof gets submitted to the blockchain and is verified. I think that model has promise for certain applications. The issue, and then before I get into my issue with it, let me tell you what Aleo is. Aleo gives you an option. You as a user can generate the proof yourself, or you can outsource it. Totally up to you. The reason why I think client-side proving, where you as the user generate the proof, is valuable is especially for these identity use cases. Because if you're just gonna trust a server to compute a proof on your behalf, I think there are cases where you're not gaining much more by having the cryptographic proof than if you just have the server vouch for you, right? You think about OAuth, that's basically what it is. Like, hey Google, does Alex have an account? Yes, he does, okay. And they just kind of take their word for it. So I think for certain use cases, particularly around identity, I believe that client-side proving as an option is really important. And so we have that option in Aleo. Now what's the trade-off? The trade-off is that it can take 3 minutes to verify a signature, right? So what's Aleo, when people ask me what's the TPS of Aleo, 50 transactions per second, which you can batch, and like I said, each transaction can contain 36 individual transitions. So call it 1,500 max. Now, those transactions though are not like a signature verification. One signature verification can take a very long time to prove. So we can talk more afterwards if you have more questions about that, but hopefully I'm glad you asked that question because I think it does highlight why we chose to go and build our own layer 1. I think I got time for one more question. I might be pushing it here. One more question. I saw your hand first. I'll find you after. Go ahead.
You've gone over some very interesting use cases for zero knowledge proofs, and I think you definitely made the case that you're making a lot of progress on the technical obstacles of Aleo. Why, in your opinion, is this not everywhere right now? So what are the obstacles that prevent this from being away from it?
Yeah, I think it's slow. I think to do client-side proving is still a little bit too slow. I mean, to do a signature verification of or to verify a hash, for example, using SHA-256, still several seconds, right? And so if you're thinking about an end-to-end TLS proof, like saying, hey, I have a TLS section, I received some messages from another party encrypted, and I want to prove those messages have some characteristic. To do that on a server is actually practical today. But I think to do it client-side is still very slow, right? So what's missing? I think what's missing is ultimately the same thing that powered, the internet. In early days of the internet, bandwidth, like, I remember dialing up, it's like, 56-bit modem, like it was really slow. All these, like, real-time video didn't exist, right? But people built that higher bandwidth connections, processors, and for server hardware specifically that was optimized for doing the cloud model. And I think, and I believe that in the future, we'll see cryptographic chips, or at least hardware that's optimized for cryptography in future chipsets for phones and for computers and for everything. So I think we're just at the very beginning of that curve. And I think the reason why I harp so much on commercialization is I think to get there, we need to demonstrate that there's a real market for Web3, for blockchain, and for ZK, and then the investments to make better hardware, faster hardware will come. Guys, this has been a really fun session. I am sorry, but I have to cut it here. I will be around the rest of the day. Anybody wants to find me, feel free and find me and ask a question. Thanks.